All right. So, bringing those files in. You're in your new project. You right-click on the project itself, add, existing item. It'll bring you up to Windows Explorer. You'll probably want to go back to the projects folder or wherever you keep all of your projects. Navigate into the project itself. And then for me, I put them in the models folder. For you, they're probably right here on the root. You'll want to grab everything that's a CS file, probably except for program. If you grab the program file, then you're going to cause all kinds of havoc to your program because that's a command line or a console app. Program.cs, it's not for the Windows form. So you'll cause a bunch of brouhaha. Last of the files you want, add. The add will actually, it's going to copy those files out of that existing project into the new one. So you now have a copy of them. So you can always go through and do your slick ninja programming stuff on this to make it work better. And if you totally blow it up, you still got your old copy that you can always rely on. Okay? All right. So for this week, in the syllabus, I originally talked about showing inheritance, interfaces, and generics. Instead this week, I'd like to focus again more on just classes and class construction and taking models. And we may touch on inheritance as we go through this, to give you kind of a taste of what you can do with inheritance. Interfaces I'm going to leave for the next week because when we get back we're going to start talking about databases, and I want to show you this concept of dependency injection, and that's really where interfaces start to give you a lot of control, is the ability to do dependency injection. So, what I'd like to go ahead and model is the ability for me to go in and create a program that allows me to put in the name of a student, allows me to drop down and select a class or a course and have that student sign up for that class. So it'll be a simpler example, but similar to what you're going to have to do for your midterm. So I want you to at least have in your mind what these mechanics are and what they should feel like when you build this application. All right, so starting from the ground up, we're going to need at least 2 classes. We're going to need a student, and I want to make this interactive, so I want you guys to actually be thinking instead of watching me program, because one of the things of feedback I've gotten from a lot of you is, it makes sense when you're doing it, but when I'm doing it, I have no idea what's going on. So I want you guys to be thinking about it. I want you to be interacting with this. Make mistakes here, because now is the time for you to learn. All right, so I have a student. So what do I need to put in this student?
Name.
Okay.
Number.
What?
Yeah, number in this game.
The number?
Yeah, and number. Right.
Oh, like student ID number. Okay.
Each student could have one, could be taking one class or several classes.
Okay. They could be taking, they could be taking any number of classes.
Yeah.
So what do we need?
A collection.
Of?
Oh, well, we're going to make another class.
Okay.
Which called class, I suppose. Course. Or course.
Course, okay. Alright. So we'll generate a new class called course. It's a good thing we didn't call it class. That would be a tongue twister. Alright, so Visual Studio creates me another empty class file. So what do I need inside the course?
Course ID.
Course ID. What else?
Professor.
Professor. What data type?
Student. Or, no,
Professor.
professor.
Oh, professor.
Lens.
That is not what I want. Stop trying to know what I want. Okay. Subject.
Also subject, maybe class subject. Subject.
All right. What type?
Subject.
Type subject?
Yeah, that's class
Well,
subject.
what if instead of subject we call it class name?
All right. I think we do need a name.
Subject would be the name. It is.
Okay, that's fine.
I think subject is a good one. So if you're taking a programming class, there's 3 or 4 programming classes. So the subject is programming, but each class could be programming 1, 2, contemporary programming, blah, 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 blah.
Look at it that way, then yeah.
Keep splitting into different classes, like.
Right. Mm-hmm. Now, I think we could do an entire class of type subject, but I think for this it'd be too complex. But there are situations where, and that's part of the beauty you have with these properties, is that you have the liberty, as your program evolves and changes, you can go in and say, I really need more complexity in the area of subject. I need to be able to actually sort them maybe by a certain order, or I need to build a hierarchy of subjects, or whatever that may be. So being able to go in and change it from a string to type subject has some merit. Yeah?
Before you go on, I don't understand how you can use data type professor. Can you
Sure.
do that again?
Sure. So let me do 2 things as I kind of go through this. So data type professor, property name professor.
Right.
Okay? This one, it doesn't exist. The class professor for the data type
Right now.
doesn't exist. So I'm going to do a control period, get to my accelerator, and I'm going to say, go ahead and generate a class.
So you can generate another class, and if you generate the class, you can use it as a data type there.
Exactly. And that's what your classes are there for, is for you to use them as data types. So anytime you say, oh, I need a data type that represents something, go make a class. Your classes are you modeling data types. So you are given the power through the creation of classes to build any data type you want. That was a light bulb, wasn't it? Good. That's what I want to see, light bulbs. All right.
So I have a question about that though.
Yeah.
So in some programming conventions, I know that Microsoft did this with Visual Basic, they would say, if you declare a string, when you declare the variable, the first 3 letters should be str.
Uh-huh.
When you declare an integer, the first 3 letters should be int.
Right.
Is there anything that applies? Because I kind of come from the same place that I think he asked that question. Professor and professor, I have they're different colors, so I can distinguish them, but just logically, sometimes it's hard for me to keep the 2 separate. So is there a naming convention that's used anywhere to differentiate them, or is that just the way that it should be done? You know what I mean?
There is no required convention. So yeah, I know what you're talking about. In VB, there was always the Hungarian notation is what you're referring to. That convention of you put a prefix that helps describe the data type of this variable or of this property. It's a convention. It's not required. Even in VB, it wasn't required. It was just a best practice.
Yeah.
A lot of the initial literature that came out from Microsoft was get rid of Hungarian notation. Don't use it. Use descriptive property names, variable names, because those are more important than these notations, because you can only make so many combinations with 3 letters. So that made some sense. That being said, you have to look at the structure of the statement. The structure and the order at which things appear in these declarations have a lot of power. They have a lot of importance. They're not just arbitrary. So when you look at a property declaration, it's always going to be scope, public, private, protected, internal. Then it's going to be the data type, and then the actual name of the property itself. Now, we don't have to, because we made the class name professor, the property does not have to be professor. We could call it teacher. So that helps simplify or clarify it when you're looking at it here. But that use of the data type and the property name is completely permitted except for in one case. If your class name, or I should say, your class cannot have a property that is the same name as the class. Okay? So I cannot go in here, even if it was of type string, public string course. So if I wanted to call it course instead of name, when I compile, it will tell me course member name cannot be the same as its enclosing type. So I cannot have a property called course inside of the class course. So that's the only one restriction that you have when it comes to the conventions and how you name things. Beyond that, it's really the sky's the limit. Okay? All right. Anything else that we need to add to the course? Yeah.
Number of students in the course?
Okay. So occupancy. Now, would that be the occupancy or the enrollment? Or are you thinking more the enrollment?
I was thinking more of the total occupancy of the course.
So how many students can be in this course?
Yeah.
Okay. So it is the occupancy. Okay.
And then we would then probably put in one for enrollment.
Okay.
So it would be easy to find the
Yeah,
number
and
of
also
spaces left.
comparable. Also comparable, because obviously you don't want to go over the occupancy
Right.
enrollment, so.
Right. So then maybe putting something like a Boolean enrollment available. Now, you may look at that and at first glance you may not notice it. Enrollment available is only a get. Why no set?
Because in theory you would set it inside the class itself so that as soon as the occupancy and enrollment are changed or updated, it automatically updates the enrollment available. So all you can get is a yes or no, is there available, rather than being able to change it outside when nothing else is changing.
Correct. So that is one of those things that's going to be a calculated property. It's not going to be static. It's not going to be accessible. You're not going to allow something from the outside to come in and set whether the enrollment is available. It's a descriptive property that says, just so you know, this course has enrollment available. There's room available for enrollment, or there's not. So it is a calculated property that gets set by the class itself internally through its logic. So we could even go further. Instead of just making it one of those little shorthands, we could say enrollment available, return. I'm actually going to show you the evolution of an if statement. If occupancy is greater than enrollment, return true. Or, yes. Else, return false. Right? So if the occupancy of the course, the number of permitted seats in the course is 30, the enrollment is 25. When I say get enrollment available, this little chunk of code inside the get statement will process. It'll take the occupancy, it'll take the enrollments, do the math, figure out if it's greater than or less than, return true or false. That's like 1, 2, 3, 4, 5, 6, 7, 8 lines of code. Way too many lines of code for me. We could do this. And we talked about this last week. Have a logic conditional, a return statement within a logic conditional. If that statement is true, true is returned. We'll never make it to the false. If it's false, we fall right over the logic conditional, the logic statement, the if statement, and we end up hitting returns false. Okay? What if I did this? Okay? So what's happening there?
You're basically calculating whether either if the occupancy is bigger than the enrollment, then there is space available in the class.
Right. So I create a Boolean called available. Booleans by default are always set to false, by the way. I'm then saying set available equal to occupancy greater than enrollment. So the computer is actually going to evaluate that as a calculation that's happening on the right side of that equal sign. It's going to take occupancy and determine is it greater than enrollment. And if it is, it's going to return true or false. So it's going to take true or false and put it inside of available. So then available becomes true or false if true. If available, return true. If it's false, skip over the else statement, return false. All right, so we're getting a little better. We got fewer lines. Well, it seems silly to have to say if it's true, return true, else false. So why don't I just do this? Return available. Right? Okay, so now we're down to 3 lines. We could trim this up again. We could do that. Down to 2 lines. Well, if we're going to do that, do we even need available? Did I go too fast? I had everybody here, right? So available is false. Available equals occupancy greater than enrollment. Calculate occupancy is greater than enrollment. If occupancy is 30, enrollment is 25, it returns true. Available. If available, return true. Else false. My last statement was, well, if this is true, and this is true, or this is false, and this is false, I could just return available. Okay? Then I said, bool available equals false, available equals this. I'm just going to trim these together, make it 1 line, right? So declare available equals occupancy greater than enrollment. Then return available. All right, so then I'm kicking in my algebraic knowledge, and I say if A equals B and B equals C, if available equals occupancy is greater than enrollment, and then I'm returning available, why don't I just return the calculated value of occupancy is greater than enrollment? So if this is always going to evaluate to be true or false, let it do its work and just return whatever gets calculated instead of storing it in a variable. So this statement is the same statement as that statement. Okay? Because this down here is available, and we're returning available. So instead of returning the variable name available, we're just returning what this calculates as. And then I like it because you can get it on 1 line and it looks pretty again. Okay?
I don't see where it's getting occupancy in enrollment. Like, usually when I declare a function, when I declare it, I also say, here are the parameters. But I don't see what it's doing. And I like to keep that down.
So occupancy, and you probably can't see it as well because there's not enough contrast. Probably because it back there, it's even harder. So I highlighted this.
Yeah.
You see how it slightly highlighted this?
Okay.
Alright. This is this.
Okay.
This is this. So right now, if you were to run the program, create a new course, occupancy will default to 0. Enrollment will also default to 0. This will then calculate as false.
Okay.
So then when we create an instance of a course, we set the occupancy, we add some enrollments, magic happens, and there you go. So these are relying on these properties that exist. So when you talk about a method, there is no need for you to actually pass in parameters or set variables because you're relying on those properties that exist elsewhere.
Yep, I get it.
Okay. All right, so let's go professor. And we'll just do this real fast. String first name, string last name, string office number, string phone number, string email address. I also added the public scope to the class. Does anybody, well, you probably haven't really run into that yet. Make sure they're public if they're supposed to be, otherwise you get this really groovy inconsistent accessibility types error, which usually means that your class isn't public but your property is. If I delete that public there, I go back into course, inconsistent accessibility. I have a property that's public, it's using the professor class, but the professor class itself is not public. How could the property be public if the data type isn't? So that's what it's yelling at you about. So whenever you see inconsistent accessibility, go check your class and make sure that it's got public. By default, when Visual Studio creates a class for you, it does not include the word public. It assumes that it's a private class, which means that it's only accessible within the project. It's not accessible outside the project. So when you only have one project, it's not a big deal. When you end up having a class library for all of your models, a separate project from the actual application, and we'll talk about that in a couple weeks, you start to see how the scope becomes more important. And it gives you much more control over what can be seen and not seen, and sometimes why you want it that way. All right, so professor, anything else for the course? The only thing I thought of was room.
Should we include like any required materials as well?
Any what?
Required materials?
No. No, so you're going too far.
Yeah, I know.
Start date, string, meeting days. All right, there we go. Is that enough? Okay. So we have a course, we have student, we have a form, we have professor. All right, F6. Whoop. Oh, whoops. Get that out of there. Let's try it again. F6. The program, blah, 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 does not contain a static main method. I deleted my program.cs. It's even better. All right. Let's take a 10-minute break. I'll put my program.cs back in, and then we'll regroup and actually build something. Okay?